Hey everyone, welcome back to AP Precalc. This is lesson 2.14. Let's get right into it. All right, so here's the bell ringer for today. Pause the video if you haven't done so already because I'm about to go over the answers. All right, so for this one, we are given the function g of x, which is 3 to the power of x, and this whole thing squared, minus 8 times 3 to the power of x. And we want to figure out what x values will make this equal to 9. And sure, while this may look like an exponential equation, what it also kind of looks like is a quadratic equation as well, with like 3 to the power of x being just like our variable. And so what we're going to use is we're going to use the A method that we learned about last class, where we are going to take the letter A and replace it with the exponential or logarithmic function that is acting as a variable in this equation to make it a little simpler to solve. So here, we're going to replace a with 3 to the power of x. So here, we should translate this equation then into a squared minus 8a equals 9. And now let's just solve this equation for a. First, let's set the right-hand side equal to 0, and then we can factor. So we should get a minus 9, a plus 1 when we factor, and then solving each one, you get a equals 9 and a equals negative 1. Now that's great, but we're not done there. Remember, even though we subbed out 3 to the x in for a, you have to kind of tag it back in the game. So here we get 3 to the power of x equals 9, and then 3 to the power of x equals negative 1. And now we can solve both equations for x. Remember, we're solving for x, we're not solving for a. So make sure you don't forget that next step. Here, we're going to solve the equations by converting both exponentials to logarithmic. If you're savvy enough here, you could just get from the first equation, x is 2 because you know 3 squared is 9. If not, that's totally fine. You can get log base 3 9 equals x by converting from exponential to logarithmic, and then this is just the number 2. Here, let's convert this one to logarithmic. We get log base 3 negative 1 equals x. And now this is the biggest thing to look for. Remember, you cannot take the log of a negative number, and so this one would have no solutions that come from that equation. So our only answer should be x equals 2 there. And then if you wanted to, you could plug it back in and check your work as well. So what we're going to look at today is logarithmic functions in real life in relation to story and contextual scenarios. And so let's take a look at the graph on the left, which shows the average salary for a pastor in relation to how big the church size is. And so we can see a pretty clear pattern in this data, right? The first 1,000 people you manage, the more people you manage, the more you're going to increase your salary. But then as you go from maybe, let's say, 1,000 to 6,000 people, your salary is still going to increase, but it's going to increase at a much slower rate. This is what we call a logarithmic real world scenario, right? This data appears to be logarithmic and is shaped like all those logarithmic functions that we've been looking at for the past few weeks. And so these are not just found in salary to church size story problems, but also in a lot of things that we look at in our everyday lives, such as earthquakes, sounds, acidity, and many other contexts as well. So as a result, we need to be able to take a set of data that may be logarithmic and find the best logarithmic equation, like the line of best fit for that data. And so that's what we're going to cover today. And so here's using Desmos to create a logarithmic regression model. And so to do this, it's pretty easy. We're going to do what we typically have been doing for exponential, linear, quadratic, cubic regression models. You're going to add a table, plug in your 2 points, and then add a logarithmic regression model from the dropdown. And so if we take a look at example 1, it will always be given to us in this form. F of x equals a plus b ln x. So your base will be ln typically because that is the base for a lot of real world scenarios. Remember, this is the same as log base e of x. And so let's do example 1 together. This is really just coming down to using Desmos. And so these should be your two screens you should get. For example A, you plug in 3, 10 and 24, 25. This is your logarithmic regression equation here. And so we want to find the equation. That's going to be f of x equals, and in this case, A is 2.0, we'll go 3 decimal places, 75, plus B, which is 7.213 ln x. And that's our equation for A. For B, very similar. Remember, this is your drop down that you're looking at. And so here, this is going to be f of x equals negative 9.32, and then we're going to round this up to 3 plus 10.146 ln x. And that should be our two answers for A and B. So it's just a matter of plugging in the points and selecting the correct regression model. All right, so for example 2, we are given selected values of the logarithmic function that are shown in the table above, where L of x is a plus b ln x. The first part, A, use the given data to write two equations that can be used to find the values of the constants a and b for the expression shown above. And so here we're not actually finding a and b yet. We just want to write two equations that can help us find a and b. And so here, our two equations should be what happens when we take our x's and then our y values, which are really L of x there, and plugging them in to this, y equals a plus b ln x. So if we do that for the first one, right, our first coordinate is 2, 3. This is 3 equals a plus b ln 2. And then the second equation is 7 equals a plus b ln 5. And those are our two equations, right? We don't need to solve for a and b just yet, and we actually don't even need to do it by hand because we'll have access to Desmos for these types of questions. So for part B, this is what you're going to want to see on Desmos, right? You're going to want to add a table, plug in your 2 points, and then go to logarithmic equation, and that should be our answer, right? You should get the equation y equals this whole mess, which means our values for a and b are a is negative 0.0258832, and then our b value is 4.36543. And now remember, you can, if you want, leave all those, that's fine, all those decimal places, but you could also round, and if you round, make sure you give me at least 3 decimal places. So here, a could be negative 0.026, and then b could be 4.365 there, right? Right, example 3. Here we are given the same context as before, except this time we're given the actual points, right? And so these are the points that are graphed on that previous example. And now we want to use Desmos, or our graphing calculator, to find a logarithmic function in this form, right? A plus b ln p. There. So this is going to require Desmos. We're going to need to plug in all of our points in a table, click logarithmic regression. Make sure you check log mode whenever that's an option. There's never going to be an answer where you're not going to have log mode, right? So now we should get S of P, writing our equation, equals A, in this case, is negative 91.542. And I'll just write the full decimals, but you could either round to 3 places or do what I did. And then plus 29.90882 times ln x there, right? Now part B, using that equation, what is the predicted annual salary in thousands of dollars for a church for a pastor whose church size is only 500 people? So let's see here. I'm going to take this equation, I'm going to copy it in Desmos into its own thing, and then replace y with f of x. That way we can see what is our y value when we plug 500 in. And to do that, then you can just type in f of 500 and get your answer there. There we should get s of 500, really, is what it is equal to 0.3295549,863, right? So that is going to be around 94.330 thousands of dollars. So that should be our answer there. All right, so that's a good example with a story problem. Let's take a look at example number 4. Here we have the most common and preferred method to measure sound intensity is decibels. Uh, Here we have a function where this is the intensity level in decibels, has a sound intensity of I, right? And so to find the amount of decibels, we just plug in the sound intensity there. The sound of noisy traffic has this as our I value, and then this as our decibels. So that's going to be our B of I there. A loud concert has an intensity of 1. That's going to be our I, and then 120 decibels as a result, so our B of I. So first thing we want to do is write two equations that can be used to find the values for A and B. So our 2 points are going to be 1 times 10 to the negative 5, comma 70, and then we got 1, comma 120. So those are our two coordinates. Let's write our two equations. So 70 equals A plus B log, and then remember, this is an implied base 10 of 1 times 10 to the negative 5th, right? And the next one is 120 equals A plus B log, and then just 1. Now we want to find the values of A and B, and this would be an example of a situation where we aren't given a calculator. And so doing that, let's evaluate these equations just a little bit more and try to solve it by hand. So for the first one here, you would get 70 equals A plus B, and now what is log base 10 of 10 to the power of negative 5, right? Well, here, 10 to what power will get us 10 to the power of negative 5? That's just going to be negative 5. So this is b times negative 5, and that's our equation there, our first equation simplified. Our next one is 120 equals a plus b, and what's log base 10 of 1, right? Think about it. 10 to what power will get you 1? That's going to be anything to the power of 0 is going to get you 1. So this should be times b times 0, which is just a. So now we know a is equal to 120, right? Because this doesn't really exist, and so 120 is a. Plugging that in, now you have 70 equals 120 minus 5b. And so here, I'm going to subtract 120 from both sides to get negative 50 equals negative 5b, and then to get b as to equal 10 there, just dividing both sides by negative 5. So now we have our values of a and b. Our equation then is, let me write it up top right here. This is going to be the decibels is equal to a, which is 120, plus b, which is plus 10 log I. Now the human eardrum can burst when it reaches an intensity level of 1 times 10 to the 4th watts per meter squared. According to the model below or above, what is the predicted number of decibels that can burst that eardrum? And so here we just want to figure out what is the decibels when this is our intensity level. So this should be B of I equals 120 plus 10 log an implied base 10 and then 10 to the 4th. This is going to be just positive 4. So this is equal to 120 plus 10 times 4, which is 120 plus 40, which is 160 decibels. And so that should be our answer for part C. And so if it's simple computations like this, then sometimes you may not be given a calculator, so just be on the lookout for that. All right, now example 5. This is our last example for the day. This is probably the most important example though, because you will see one of these questions on your next test, and you could see one on the AP exam. So very, very important. All right, so here, every state in the U.S. has representation in the U.S. government. Remember, this is the House of Representatives, not the Senate, but the number of reps that each state has is proportional to the population of the state. In 1940, which is T equals 0 here, the state of California has 23 representatives. 20 years later, in 1960, California has 38 representatives. And then the number of representatives can be modeled by function R given by this equation. And now take 1 second, look at that equation, and see what is different from that equation in comparison to every other example we've done before today, in like example 3, 2, and 1. And that is going to be that t plus 1 there. That is very, very, very important, and we're going to get to that in about a minute. So just pay attention and keep in mind that that's different from the other ones that we've done in the past. And so this is where, again, our y value is just the number of reps that California has, and then t is the number of years since 1940. For part A, I, we are using the given data to write two equations that can be used to find the values for A and B. So we're going to take our 2 points, which are 0, 23, and then 20, 38, and plugging them into this equation right here. We're not going to change anything, so this is going to be 23 equals A plus B ln, and then 0 plus 1. So make sure you include that plus 1 there, very important. But you don't even have to simplify that. You don't even have to do 0 plus 1 is 1, right? So very easy there. The next one is going to be 38 equals A plus B ln 20 plus 1, and that should be good there. So those are our two equations. We're done with part I. Now AII. This is going to be find the values for A and B. And this is the tricky part, right? Because if we just plugged it into Desmos, right, our Desmos equation is not that. It is A plus B ln x. Whereas this is A plus B ln x plus 1 is our equation that we're looking for. So what are we going to have to do? Well, we're going to have to essentially add 1 to every single x value, because that's what this equation is kind of telling us to do. And so here, instead of 0, 23, we're going to plug in 1, 23. We're going to leave our y values the same, right? So we're not going to have to worry or touch our y values, but know to add 1 to your x value. Because essentially this is our x value, right? Those. So not 0 and 20, but 1 and 21. 21 should also be our x value for the second coordinate, which would pair alongside 38. Once you have those two coordinates, we are going to plug them into Desmos and then use a logarithmic regression. Right, so here's our 2 points. Click logarithmic regression. It will spit out an equation. Don't worry that this isn't the same thing. These are your values for A and B because we did that t plus 1 transformation already by adding 1 to our x coordinates. It will always be like this. You will never have to like subtract 1 or add a different number. It's typically just going to be plus 1, and that's because you just cannot take the log of 0 or a negative number. So a lot of people forget ln 0 doesn't exist. And so when you have a starting point at 0, that's why we kind of want to offset that. So here we should get our value for A. In this case, should just be 23. And then our value for B here should be equal, as a decimal approximation, to 4.927, rounding to 3 decimal places there, right? You can have more, that's fine too. And so those should be our 2 answers for part A. All right, so for part B, the same context as before, we first want to start by using the given data to find the average rate of change, which is another word for slope, of the number of reps in California in representatives per year from t equals 0 to t equals 20. Express your answer as a decimal approximation and then show your work. And so here we could use either of the two pairs of points. We could use what we used in part 1, AI, which is 0, 23, and 20, 38. Or we could use the two coordinates that we used in part AII, which is 123 or 2138 as our second coordinate. And so as long as you use the two coordinates from the same pair, it doesn't matter which two you use because you're going to get the same answer when you calculate slope. So let's do that now. Let's set this equal to, we'll do 0, 23 and then 2038 as our two coordinates. And so this is going to be 38 minus 23 over 20 minus 0. This is equal to 15 over 20, which is 3 over 4, which then, remember to convert it to a decimal, 0.75. And that's our answer. We're done there. Part 2 is a new question. This is the final type of question that you could see for part 2, which is interpret the meaning of your answer from 1 in terms of the context of the situation. So this is a good template right here that will typically guide you on how to answer this question. And so the first thing you want to do is talk about the time frame you looked at, right? From t equals 0 to t equals 20. And this is going to be from the story prompt. So even if you used 123 and 2138, you want to say from 0 to 20 when you give your answer to part 2, because that's what the question was specifically asking for. So from t equals 0 to t equals 20 on average. This is a good two words to have, but not necessary. I would say then and then we're looking at what changes. So the number of representatives. And then you could give the full thing in the U.S. Congress from California. But honestly, if you just have, for like this problem, the number of reps, that's okay. And then was, and you either want to say increasing or decreasing, and that's going to be based on whether your slope from part 1 was positive or negative. If it's negative, then you just want to say decreasing, and that kind of tells it that it's a negative number. But in this case, 0.75 is positive, so I would say was increasing. And then at a rate of. And now we want to give our number, our slope from part 1, so 0.75, and then we want to give our x variable per our y variable. And you'll typically find this right here. So in this case, it's in representatives per year, so let's finish it off with that. So it was increasing at a rate of 0.75 reps, and then it's going to be per year. And this is a perfect answer to part 2. All right, part 3 is let A of t represent the estimate of the number of reps using the average rate of change found in part BI. Let's just sketch a quick graph here, right? So our graph should look like this. This is R of t, is that red line there. And now let's sketch, what does A of t look like here? A of t is going to be a straight line like that from, we'll say this is 0 to 20, right? Let me put that in red. But that is what A of t should be. From 0 here to 20, and those are the 2 points that form that straight line. Now we want to explain why in general, when t is bigger than 20, so we almost want to have tunnel vision on this line, and only look at when t is bigger than 20, we see that this straight line is going to be above the logarithmic function, right? This blue line is A of t, and it's going to be above the logarithmic function whenever t is greater than 20. And when we want to explain why, including a reference to the graph of r and our relationship to A of t, and so here we have kind of like a cookie cutter answer for this, but that answers the question completely. And this is going to be, first we want to say, what are we showing? So we want to say A of t is going to be bigger than R of t when t is, I mixed it up, when t is bigger than 20. and then because, and we want to mention two things. The first thing is the concavity of our regression model. So R of t is concave, and then in this case down. And we want to talk about that secant line. So and the secant line from t equals 0 to t equals 20, or formed between 0 and 20. Something, so here, the second thing is that you need to talk about a secant line and talk about the 2 points that form it, which is, in this case, 0 and 20. So here we would say, and the secant line from t equals 0 to t equals 20 is above r of t. So there's two things I'm looking for. The first thing is you have to talk about the concavity. You have to, otherwise you won't get points. And the next part is referencing the secant line and then from 0 to 20 specifically. Otherwise, it could just be any random secant line. It could be 2 points like that, which is useless in answering the question. So that's why you want to specifically say between 0 and 20 there. So hopefully that makes sense. Let's move on to the final part here. All right, so for part C, this is going to be a new type of question that you will see. And so here it was reported that the number of reps in California actually decreased each year after t equals 20. So we're going to be looking specifically past t equals 20. Explain why the error in the model R increases after t equals 20. And so let's draw two lines, right? The first line I'm going to draw is our model R. And that's going to be just this red line right here that runs through those points. And so model R is going to be constantly increasing. Now I'm going to draw another line, which is, I'm going to call this what actually happens. So model R is simply just a prediction, right? It doesn't tell us any actual information, but we are given that past t equals 20, the actual number will constantly be decreasing. We don't know at what rate, right, what the slope of that line is, but we just know it goes down constantly. And so if we take a look at this, this is going to be our error, is the distance between our prediction and our what actually happens, right? So let's point this out. You don't have to write this in your answer, but error equals distance between model R and what actually happens. So let's take a look at our error, right? Our error is constantly just going to get bigger and bigger because this is going up and this is going down. And so how can we answer this question? Well, let's just point out and reply with what we see that I just showed. So I would say here the error increases after t equals 20 because the number of reps is decreasing, or is actually decreasing, while R of t is increasing. So the distance between them is increasing. Right? So now that I have that down, it's really important to know what I would be looking for a correct answer. And so what I'm going to be looking for is a few things. The first thing that I'm looking for is for you to actually show or show that you know that the number of reps is decreasing while the function model is increasing. As long as you make that connection between the two and show that one's increasing and one's decreasing, and you have which one is obviously increasing correctly, then that should get you the point. And then making some sort of general statement about how, right, they're getting further and further apart, the distance between them is increasing, the error is increasing. A general statement like that, that should get you full points for this question. This is probably one of the biggest examples to go over, so make sure that you understand these. You'll have one or two of these in your homework. If you have any questions, please come see me in office hours, and I will see you guys later. Thanks.